สวัสดีครับ Hello everyone. Today we learn in chapter 3. We will talk about the mathematical in computer system. After you learn, I think you will understand the binary multiplication, and also I show you the techniques generate the random value that is related to the generate random when you write the computer code, maybe sometimes you need to generate a random value to use in the machine learning system. That is the technique for creation the circuit about the generate the random generators. And the next I show you the IEEE 754 that is about the floating points. And finally, we will talk about the error in computers such as NA, NaN, INF. Okay, here we have 5 topics. The first topic we will learn about the binary multiplication. Before we move to the binary multiplication, I will show you that I think you learned is in during the elementary about the multiplication. Example, I have the number 2 multiplied by 5 is 10. Now, I set up the value in the binary like this. This is a 0, 0, 1, 0. This is a represent 2. And 0, 1, 0, 1. This is represent 5. Then 2 multiplied by 5, this means this is the 2 5 times. 2 5 times. So we will write here, this is 2. And look at here, this is a position at this. This is the same position here. And then the next, this is 0 in the second, and then I put 0, and then the third, this is a 1, I put 2 again, 0, 1, 0, 0. But the number is achieved by 3. This is 0, 1, 2, 3. No, 1, 2, 3. Yeah, 3. And then we add all this and have a result. This is 0, 1, 0, 1. 0, 1, 0, 1. This is 10. This is a 2, 1, 2, 4, x. X at 2 is 10. Okay, again here, 12 multiplied by 9. Do you think about how to write it in the binaries? Yeah, exactly. That is 9 times. This is 9 times. So when it's 9 times, I look at the logic at this represent only 1 here. We have a 2 position at the first and the fourth. So I write the first section. The first part is 1, 1, 0, 0. This is come from 12. And then we have 2, 0. Write 2, 0. Don't forget to shift left. And then write 1, 1, 0, 0. This is shift left 1, 2, 3, 4 times. So here we add it together. We will have these numbers. The output is 2, 4, 8, 16, 32, 64, and 100x, maybe 120x. Yes, to add it together, we will have the result in the decimal value. Now here in this topic, we talk about the binary division. The binary division, the techniques of the division, we have 2 techniques. For this class, we talk about only long division. And in the complement method you will learn in the about the during a part about the digital circuit. Okay, here before we move to the long binary division in the binary, we will remind about the decimal long division. I suppose I have a value 123 here and divided by 4. So when we divide it in the decimal, we put it in this form by 4 and have this symbol 173, and then I consider 4 with the digits, the left hand side digits first. So here 4 is less, this is a 4 is less than 1, right? No. So this is, I put 0 on the top, and then I compare 4 with 17. Change from 1 to the next digits, that is 17. 4 is less than 17, right? Yes, I put 4 because it's 4 by 4. This is a 16. So I write 16 here and then do the subtraction. And after do the subtraction here, this is a remain only 1, and I bring the 3, move it down here, and then consider 4 with 13. So for this 13 is a 4 multiplied by 3 is 12. So I put 3 on the top and write 12 and bring the 12 here to do the subtraction. This result is 1. So the result is 43. It is an example about the decimal long division. Now we look at the binary long division. For the binary long division, do the same like as the decimal long division, but it's different by write the number in form the binary form. So here I suppose I have a value 1101, not thousands, 101, and 10, not 10. Here I write 10 and 1101. Then I consider 10 by compare with the 1 here. So 10 is less than 01. Again 10, not 10. This is a 10 is in the decimal is 2. 2 is less than 1, right? No. So I put 0 on the top, and then I move to the next letter here. Compare 10 and 11. So 10 is less, this is lower than the 11. So I put 1 on the top and write 10 here. Do the subtraction in binary. The result is 1 subtraction 1 and 1 subtraction 0. Put 1 here, and then again I bring 0, move it down, and compare 10 and 10. So 10 is 10 is the same, but cannot do the subtraction. I put a 0 on the top, and then I bring 1 at the last digit here to be 101 and compare 10. So this is can do that. I put the 10 and do the subtraction here. This is remaining the 01s, and don't forget put 1 on the top. And here the output before you write the answers, you should bring 101 and do the addition with the 01. You will get the output. It is 0110. Here this is example of the for the binary long division. Now we can write the code in the binary form by write code in the C language. I know you don't learn about the C language before, but I think if you write in C language more, you will understand the syntax and language in the C language automatically. So the first step, you don't install the C language in your computer. You can open it on the online GDB. We will open in online GDB and put this code to test this online GDB. Okay, now you open the browser and enter to the online GDB. Now I enter to the website, the onlinegdb.com. Here, this is online writing code in many languages. You can select any language here. And when in this code, this is a C language, I use a C language. And you can adjustment the program. Here now you write this code, put here, and after you write is complete, you click start, click run to run the program. Now I will write the code a few minutes. Now I write the code complete. Now I will compile the code, click run. The code here, this is a generating output at the below. The code I will explain in each line. This code, this is the function about the pin binary. Inside the function, get the value numbers. Example, I write the number C is a result from A divided by B. After get do the division, this is the send the result via variable A to this, put it in the variable number, and then the number do the shift. Here this symbol is a shift right one, shift right once, and then do this function again. This is a call by itself. It's called the recursion function. That means this function calls itself, and then calls itself until the chip cannot do the chip. The chip cannot do the chip. We'll put the number by in this is a form we call the ternary. It is right as the if condition. When number and 1 is 2, we'll put output 1, letter 1, and if not 2 is 4, write the letter 0, and do this back after shift right until to the end. The character will do the return is back and put the character in each time from when move it back. After move it back, we'll get the sequence of the characters. We'll return it to the screen and call this function in the code. Yeah, this is an example for this code in C language. Now the C language have the operators about do the logical that is here. It is an AND, OR, exclusive OR, complement, shift left and shift right. In this is an example, you can change it from the example 3.1. I show you the division in line 14 is A division divided by B, and in line 14 again I change it to the exclusive OR. Here this is example code by modify. In this code, this is a convert in the integer to the binaries by use the function like as this function, but this function not do the recursion. So here this function do the recursion, for this function not do the recursion. Okay, you can test this code, write it on the online GDB.